Hi, I'm ATH. Welcome to this lesson in my chemistry series on displacement reactions. Before we get into displacement reactions themselves, I think it's important to recap on a type of metal reaction that we already know about. We'll take a quick look back at competition reactions, because displacement reactions are very similar to competition reactions. So if you understand one, you should hopefully understand the other. But first, let's head up our notepaper like this, with your name, the date and today's title. Pause if you need to get yourself organised. In a previous lesson, we looked at competition reactions between metals and metal oxides, where metals fought over or compete with each other for oxygen. The metal that ends up with the oxygen is the metal that's higher up in the reactivity series. Here, magnesium and iron are competing for oxygen. At the start of the reaction, the iron has the oxygen and is hence iron oxide. The magnesium manages to take the oxygen away from the iron in the reaction and forms an oxide, leaving the iron on its own as a pure metal. The magnesium ended up with the oxygen, so magnesium is more reactive than iron. There would have been lots of evidence that a reaction took place here, such as the production of heat, light and smoke, as well as a change of materials. The reactants at the start were a silvery metal, the magnesium, and a reddish powder, the iron oxide, and these changed during the reaction to a white powder, the magnesium oxide, and a greyish metal, the iron. In order to get the reaction started, we do have to heat the two chemicals together, so we add heat over the arrow in the word equation. Let's watch this VT of another example of a competition reaction to remind us further. On the left we have some powdered zinc metal, and I'm adding to that some copper oxide. Both are in powder form, as that increases the surface area and therefore increases the speed of reaction. So just making sure that they're thoroughly mixed in order for them to react with one another and compete for the oxygen in the copper oxide. So we're now just spreading these out on a heat-proof mat. So we've got zinc in the form of metal powder and copper oxide. So they're going to be competing for the oxygen that the copper currently has. So we're heating at one end, and because this is an exothermic reaction, there's a lot of heat given out, which means the reaction can continue. We've got a lot of evidence of a reaction here. We've got light, we've got heat, we've got smoke, and a change in the materials. You can now see some yellow zinc oxide powder around the outside of the products here, and if I manage to get this off of the heatproof mat and wash it, we can see underneath the reddish brown copper that's left behind. The equation for that reaction is zinc plus copper oxide with heat goes to zinc oxide and copper. The zinc is higher in the activity series as it was able to gain the oxygen from the copper. Let's make a note of what a competition reaction is and the example we've just gone through. Now have a go at the following questions on your notepaper to make sure that you're happy with competition reactions. I've added a reactivity series next to the questions to help you with your answers. Pause the video when shown and unpause when you're ready to mark your answers. Let's find out how you did. So question 1. Would aluminium and zinc oxide react? So if we have a look at the reactivity series, we can see that aluminium is the fifth metal down and zinc is just below it. So aluminium is more reactive than zinc. So we started off here as our reactants of aluminium and zinc oxide. So the zinc starts with the oxygen. Aluminium's higher, so it will be able to take the oxygen away. So your answer should have been yes for 1 mark. So question 2. Would lead and iron oxide react? So lead, we can see there, is just below about halfway, and iron is a couple of places above it. So iron has got the oxygen and it's more reactive than lead. So lead won't be able to take the oxygen away. So there's going to be no reaction. There's going to be no change in the chemicals here. So the answer to question 2 should have been no for 1 mark. So question 3. Write a word equation for the reaction between calcium and tin oxide. So again, if we have a little look at the reactivity series, calcium is quite high. It's the 3rd one on our list here, and tin is about halfway down. So there is going to be a reaction. So we're going to start off with the reactants of calcium plus tin oxide goes to, and calcium is going to take the oxygen and become an oxide, and tin's going to be left on its own. So calcium oxide plus tin. Because there's actually quite a gap between calcium and tin, this will be quite a dramatic reaction. So I'm giving 4 marks for the actual chemicals there, so 2 marks for the products and 2 marks for the reactants, and the 5th mark for drawing an arrow and not putting an equal sign. So what's the 6th mark for? Well, on these reactions we have to heat them to get them going, so we need to add heat for the 6th mark over the arrow. Question number 4. In a reaction between magnesium and copper oxide, write 4 bits of evidence you might notice that a reaction has taken place. Well, what I've put here is that you've got heat produced. It's an exothermic reaction. You would have light produced, and you'd also have a change in chemicals. So we'd end up with a white powder being produced, the magnesium oxide, and a reddish brown metal being produced. That's the copper. You could also have had smoke being produced. So 4 things for 4 marks there. Question number 5. Mercury reacts with silver oxide. Lithium reacts with mercury oxide. So write these 3 metals in order of reactivity. So 2 of those aren't on our reactivity series, so we're going to have to work this out. So mercury reacts with silver oxide, so it's taking away the oxygen, so we know that mercury is above silver. Lithium reacts with mercury oxide, so again the lithium is taking the oxygen from the mercury, so lithium is higher than mercury. So if we put those 2 bits of evidence together, our answer should have been lithium as the most reactive, then mercury, and then silver for 3 marks. Total marks for that was 15, so hope you got most of those marks. If not, have a little look through, have a little think, see where you went wrong, and hopefully fill those little understanding gaps. A similar sort of reaction to competition reactions are displacement reactions. These take place between metals for a metal salt, such as a metal sulfate or a metal nitrate. These sorts of reactions take place in solution, so there's no need for heating the reaction to get it started. They start on their own. These displacement reactions are similar to competition reactions, but instead of competing for oxygen, the metals are competing for the salt in the solution. And the metal that ends up with the salt is the most reactive. Let's have a look at an example to help us understand what's going on. Here we have some silver nitrate in solution, and I'm adding to it a piece of copper. As you can see, fairly quickly a reaction starts to happen. What's happening is that the copper is actually displacing or taking the place of the silver to form copper nitrate. The silver is now coming out as little crystals and coating the copper. So you can see the silver crystals forming on the outside of the copper. And if I remove the piece of metal, you can quite clearly see the silver. The word equation is copper plus silver nitrate goes to copper nitrate plus silver. We didn't heat, so there's no heat on the arrow. The copper won the competition as it ended up with a nitrate, and hence we can confirm that copper is above silver in the reactivity series. We say that copper has displaced the silver. The copper has taken the place of or displaced the silver. This is why they're known as displacement reactions. So my joke for this lesson: what salt is a policeman's overtime? Copper nitrate. Bum bum. To our notes. Think about this reaction and then see if you can answer the questions that follow. So here we have a lovely blue solution of copper sulfate, and into the copper sulfate solution we place a grey iron nail. If we leave it for a few minutes, then that starts to change. The solution goes a deep green colour, and there seems to be a reddish brown coating on the nail that's in the solution. So have a think about that reaction and then have a go at these 6 questions. So let's see how you got on. Firstly, let's have a think about this reaction. So we've got copper sulfate solution and we've added an iron nail. We can clearly see a reaction has taken place because there's been a change in the materials. So we've ended up with this green solution and a reddish brown solid. So all that could have happened there is that the iron displaced the copper, took the place of the copper and formed iron sulfate, which meant that the copper was then left on its own as a metal and therefore started to coat the iron. So now, having thought through the reaction, let's have a quick look at the questions. So question 1, what is the green solution? Well, that's going to be iron sulfate for 1 mark. Question 2, what is the reddish brown metal coating the iron? Well, that's going to be the copper, so another mark there. Question 3, write a word equation for this reaction. So I've given 3 marks for this. So 1 mark for getting the reactants right, copper sulfate and iron, doesn't matter which way round you put those. And then another mark for the products, which is iron sulfate and copper. Again, doesn't matter about the order there. The 3rd mark I've given for drawing an arrow, but not putting heat on it. Question 4, what displaces what in this reaction? Well, the iron displaces the copper. The iron takes the place of the copper in the salt. Question 5. Which metal, copper or iron, is higher in the reactivity series, and how do you know? So 2 marks here. So the first part, iron is going to be higher in the reactivity series than the copper. So that's 1 mark, and we know that because the iron has displaced the copper. Question 6. What would happen if I added copper to iron sulfate, and why? So question 6, I'm giving 2 marks, 1 for the explanation and 1 for what happened. So the first mark, no reaction, and then the second mark is that iron is above copper in the reactivity series, and we know that because of the reaction that's just taken place. So total of 10 marks there. Hopefully you got most of those. Displacement reactions are quite straightforward if you're happy with the idea of the reactivity series and happy with competition between metals. Just like competition reactions for oxygen, displacement reactions take place between metals, but this time for the possession of a salt. The winning metal is the one that's higher up in the reactivity series. If no reaction takes place, then there has been no change in the metal salt. So the metal that started and finished with the salt is the one that's higher in the reactivity series. There are 2 bits of evidence that we can see to show that a displacement reaction has occurred. The change in colour of the solution and a metal being deposited or coated onto the metal that we added. So let's make some notes on the evidence. Now let's have a go at some quick-fire multiple choice questions just to make sure that we understand displacement reactions. Okay, let's see how we got on. So, will a piece of aluminium react in a solution of copper sulfate? Well, aluminium is above copper, so yes is the answer there. Will lead react with zinc nitrate? So lead is below zinc in the reactivity series, so the answer there is going to be no. Will magnesium react with iron sulfate? Magnesium is way above iron, so the answer again is yes. So what are the products when tin is added to silver nitrate solution? Well, tin is above silver, so they will react. The tin will take the nitrate away to become tin nitrate, and then we're left with silver. So the answer is B. What are the products when zinc is added to tin nitrate? Well, zinc again is above tin, so there will be a reaction. So the zinc will remove the nitrate and become zinc nitrate and leave the tin. So the answer is C. What are the products when silver is added to copper sulfate? Well, copper is above silver. Copper's got the sulfate already, so there'll be no reaction. I hope you did well there, showing that you understand the concept of displacement reactions. Now let's put that understanding to the test and have a go at some longer exam-style questions. So let's have a look at how you did. Before we look at the questions, let's have a little look at the table and get our heads around that. So along the top there, we have the sulfates for zinc, copper, nickel and calcium. And down the left-hand side, we have the pure metals. And then the results of the reactions in the table. So if you have a look at zinc, that reacted with copper and nickel. So we know that zinc is above copper and nickel. It didn't react with calcium, so we know calcium is higher than zinc. Copper didn't react with any of them, so that means that it's at the bottom of the 4 metal reactivity series. Nickel didn't react with zinc, but it did react with copper. So we now know that it goes zinc, nickel and copper. Calcium reacted with both zinc and nickel. So question 1, is it a tick or a cross in box A? Well, box A is showing the reaction between nickel and calcium sulfate. Well, if we look at the reverse reaction of calcium and nickel sulfate, we see that there was a reaction. The calcium took the sulfate, therefore calcium is above nickel. So when we do it the other way round, calcium's going to keep hold of the sulfate because it's higher, so we're going to have no reaction, so a cross goes into A. In B, we've got copper sulfate and we put in some calcium. Again, if we look at the reverse, when we put copper into calcium sulfate, nothing happened. So the calcium is above copper. So the calcium will take the sulfate away from the copper. So B is a tick. Question 3 asks us to put the 4 metals in increasing reactivity. So copper is first because that has the least reactivity because it lost all of its 3 reactions. Nickel then comes next, then zinc and then calcium, which won all of theirs. I put in 4 marks there, 1 for each of those. If you got those 4 in the right order but you did it decreasing instead of increasing because you didn't read the question, then give yourself 3 instead of 4 for that. It is important to read the question carefully. So question 4, in a reaction between copper sulfate and iron, we get a reddish brown metal produced. That is, of course, copper. So question 5, we're looking for 2 tests to prove that reactivity series they've given us there. So the best thing to do is to do some positive rather than negative reactions. So I've put here that we add nickel to tin sulfate. They will react, showing that nickel is above tin. And then if we add tin to copper sulfate, then again we'll get a reaction because the tin will take the sulfate and therefore we know tin is above copper. So there's a total of 10 marks for that, and hope you got most of those. Well done, and I hope you're happy with displacement reactions. Remember, you can always go through this video again or come back at a later date to revise that section. So thanks for learning, take care, and see you again soon.